Okay, here are solutions to perfect problem 6 from Math 111. Might have gone a little overboard again here. This is a pretty long problem, but it'll be good practice for the quiz. So the first one, find and simplify f of x. Okay, f of x is this mess. So f of x is f of 2x minus 3 over 5 minus x. So what I can do is replace, so now I want f of this mess, which I replace all the x's in this equation with 2x minus 3 over 5 minus x. So what I get is 2 times 2x minus 3 over 5 minus x minus 3. So 2x minus 3 divided by 5 minus, and then instead of writing x, I can write 2x minus 3 over 5 minus x. What a mess. If it just said find this, I'd be done, but it says find and simplify. Damn. Alright, I can do that. Maybe I'll first multiply the 2 through and get 4x minus 6 over 5 minus x. See, I have minus 3 here. It would be nice if I had a common denominator. That common denominator is 5 minus x. To get 5 minus x on the bottom, I think of this as 3 over 1, and multiply it by 5 minus x over 5 minus x. So what I get is 15 minus 3x. Alright, now on the bottom here, same, my common denominator, I guess I want my common denominator to be 5 minus x, so think about this as 5 over 1. Multiply that through, and you get 25 minus 5x over 5 minus x minus 2x minus 3 over 5 minus x. And now what I have is 4x minus negative 3x. So what that is just x. Negative 6 minus 15 is negative 21 divided by 5 minus x. Let's see, negative 5x minus 2x is negative 7x. 25 minus negative 3 is 28 over my common denominator of 5 minus x. And dividing fractions is like multiplying, but you flip them upside down. If you flip these upside down, I guess I should show it. X minus 21 over 5 minus x times 5 minus x over negative 7x plus 28. If you do that, you get these 5 minus x's canceling, and you get that this is equal to x minus 21 divided by negative 7x plus 28. So that's f of x. Now you want me to find the domain of that thing. Okay, so for the domain, I have to first consider the domain of this guy, which maybe I'll write that domain of the inside function, f of x in this case, is equal to everything except for 5. I can't divide by 0. If x equals 5, I'll divide by 0. So maybe all but 5. And then you look over here, the domain of this thing is I need negative 7x plus 28 to not equal 0. So what I need is x to not equal 4. So domain of this guy is all real numbers except for the number 4. So my final answer is everything except for 4 and 5, which I can express as everything up to 4, everything between 4 and 5, and then everything greater than 5. Whew. Yeah, that probably could be the perfect problem in its own right, and we still have a bunch more parts to do. But I think this will be good practice. I hope it will be good practice. Now we want to find f of g of x. F of g of x is negative 3x squared plus 12x plus 8. Okay, f of x is this mess, so what I have is 2 times, instead of writing x, I'm going to write negative 3x squared plus 12x plus 8 minus 3. Remember, f of x is 2x minus 3, so I wrote 2x minus 3. I want to divide that by 5 minus x, which I'll replace with negative 3x squared plus 12x plus 8. And what I get here is, if you take this 2 and multiply it through, you get negative 6x squared. 2 times 12 is 24x. And 2 times 8 is 16. And you got to subtract 3. So we'll call it 13. And divide that by, let's see, minus negative 3x squared is just positive 3x squared. Minus 12x. And 5 minus 8 is negative 3. And I don't think this simplifies. Honestly, I didn't even look. I mean, I guess you could factor out a 3 down here. There's no greatest common factor up here. It's 1. Maybe it factors, but I doubt it does. I don't really want to look for it, so I'll just leave it right here. Find the domain of this mess. Let's see, the domain of f of g of x. We first have to figure out the domain of g of x. That's this polynomial here. All numbers work. We won't divide by 0. We won't take the square root of a negative. So we're good. So all we have to do is make sure that 3x squared minus 12x minus 3 does not equal 0. So let's figure out when it does equal 0. All right, maybe I'll factor out this 3x squared minus 4x minus 1. Let's see, hard to tell what the answer is. It doesn't really look like that factors. So maybe I'll complete the square on what's in the inside. Let's see, 3. Shoot, I want to complete the square the way I've taught you to, so I'm going to go back. Instead of factoring out the 3 there, I'm going to do this and say 3 times x squared minus 4x minus 3. Okay, and that is equal to 3 times x minus 2 squared minus 4 minus 3. This 2 came from half of this number, this 4 came from this number squared. Multiply the 3 back in, and you get x minus 2 squared minus 12 minus 3, or 3x minus 2 squared minus 15. So all that, find the domain of f of g of x. Okay, so that's what is the domain. Okay, so don't get lost in the problem. Finding the domain of this, I'm just trying to figure out when the bottom equals 0, and those will be the numbers that aren't in my domain. And so to figure that out, I want to figure out when this guy equals 0, which I can solve by adding 15 to both sides. Get 3 times x minus 2 squared equals 15. Dividing both sides by 3, x minus 2 squared equals 5. Taking the square root of both sides. Got to leave that as square root of 5. So our final answer is 2 plus or minus root 5. So what does that mean? That means that if x equals 2 plus root 5 or 2 minus root 5, we'll divide by 0. We don't want to divide by 0. Those are the numbers that aren't in our domain. So our final answer would be everything from negative infinity up to positive 2, up to positive 2 minus root 5, everything from 2 minus root 5 up to 2 plus root 5, and finally everything from 2 plus root 5 up to, I can barely squeeze it in, infinity. This right here is my domain. Oh my god, this problem is terrible. Find f inverse of x. Okay, what is f of x? F of x is 2x minus 3 over 5 minus x. So I got y equals 2x minus 3 over 5 minus x. What you want to do is solve for x. A little hard to do with 2x's floating around in here. So what you do is multiply both sides of the equation by 5 minus x. Get y, maybe I'll do it below. I'm a little low on room here. Y times 5 minus x equals 2x minus 3. take this up here to get 5y minus xy equals 2x minus 3. I want to solve for x, so let's get all the x's on the same side of the equation. Maybe add xy over here, add 3 over here, and what I get is 5y plus 3 equals 2x plus xy. So finally, to solve for x, I could factor out an x from both of these terms and get x times 2 plus y equals 5y plus 3. And so to get x all by itself, divide by 2 plus y, and you get x equals 5y plus 3 divided by 2 plus y. Didn't leave enough room, but I should go one more step. I should write this as f inverse of x. It wants x to be the variable, so instead of writing y's in there, I'll write 5x plus 3 over 2 plus x. Whew. And this right here is f inverse of x. Find the smallest possible value of a so that g of x is 1 to 1 on that interval. Okay, so wait, what was g of x? It was negative 3x squared plus 12x plus 8. Negative 3x squared plus 12x plus 8. Make sure I copied that down right. Looks like it. Okay, so really what I want to do is find what the vertex of this function is. I think the best way to do that would be to complete the square. Maybe I should change colors. This is a lot of green out here. See, to complete the square, I will put brackets around all the terms with x's in them. And then I will factor out a negative 3 to get x squared minus 4x plus 8. And then I will complete the square on what is inside these brackets. Half of this negative 4 is negative 2. So I got x minus 2 squared. Negative 2 squared is 4. So I subtract this 4 right here. This is probably enough, but I'm going to take it one step further because it'll be useful later on. Negative 3 times x minus 2 squared plus 12 plus 8. Negative 3 x minus 2 squared plus 20. So what I did is I took this negative 3 and factored it back in and then combined like terms to get to here. And the point of getting to here is because now you can view this as a parabola with vertex at 2, 20. So 1, 2, 10, 20, something like that. And so we got this parabola. Who knows what it looks like? But if we restrict the domain to everything to the right of 2 here, this function becomes 1 to 1. So what we got is that a equals 2. Okay, finally, last part. Find g inverse of x. So we have g of x up here. Basically what you want to do is change g of x into a y and solve for x. It would be a lot easier to do if you use this form right here. So I will say y equals 3 times x minus 2 squared plus 20. So that's a negative 3. And then solve this for x. Subtract 20 from both sides. Y minus 20 equals negative 3 times x minus 2 squared. Divide both sides by negative 3. You get, how should I write this? Maybe 20 minus y over positive 3. One of many ways that you could have written that. I like avoiding negative numbers whenever possible. Now I take the square root of both sides. So what I get is x minus 2 equals the square root of 20 minus y over 3. Wait, where's the plus or minus? You don't put plus or minus in here. Why don't you put plus or minus here? Because of this restricted domain. By restricting the domain, what ends up happening is we kind of get rid of the negative part. So we get x minus 2 is just equal to this guy. If you add 2 to both sides, you get x equals 2 plus the square root of 20 minus y over 3. And let's see, we want it as g inverse of x. Okay, fine. G inverse of x equals, replace the y's to make x the variable, 2 plus the square root of 20 minus x divided by 3. And that finally is the end of this monstrous perfect problem. I know it was a little bit overboard, but hopefully all that practice will make the quiz go really well this week. I've noticed quizzes haven't been going quite as well. So maybe it's a good thing. We'll see. That's the end.